As said earlier, the process of this round contains 4 steps majorly. One is with respect to subbytes, one is with respect to shift rows, mix columns and add round keys. Leaving the initial round or round 0, we are going to perform all the 4 steps except for the round 10. Until the last round. Only for the last round we are not going to perform this mix column, and the rest of all we are going to perform the same. Since we are started with respect to 128 bits of data, you can see here, let me take a message encryption, which must have 16 characters, right, in order to satisfy 128 bits. So I am taking an example, MESSAGE message followed by ENCRPTION. Do not bother about the spelling. I need to satisfy with respect to 16 characters, so I am going for this message example. MESSAGE followed by ENCRPTION. As we did earlier, we are going to convert the same here. Every character will be having ASCII value. Its hexadecimal value I am representing here. The value of M will be 4D, E will be 45, S will be 53. Similarly, again S, so 53 again, followed by 41, 47, 45, 45 again, 4E, 43, 52, 50, 54, 49, 4F and finally 4E. As we did with respect to key generation, even with respect to round, initially the first 4 elements we are going to consider as the first column, and the second 4 elements we are going to bother with respect to second column. The third 4 elements I am going to bother with respect to third column, and finally the last element we are going to bother with respect to this column. So the first column would be 4D, 45, 53, 53. The second column would be 41, 47, 45, 45 again. The third column would be 4E, 43, 52, 50, and the last column would be 54, 49, 4F and 4E. This is the generated one. This is my message signal, right? This message state, I need to perform the XOR operation with the previously generated state, nothing but key 0. So these are the values that we got from the key 0. I'm going to perform this XOR operation with respect to each element. Okay, the first element of this message state, I'm going to XOR with this state. So this would result me as 19. Let me check it. 4D, nothing but 0100 followed by and 54 0101 0100. Performing the XOR operation would result 1001 1000. So the resultant will be 19. Perfect. So this is my element. Likewise, I am going to take the second column, second element of this message state, performing the XOR operation with this second element of the key 0 state, and I am going to generate 12. Similarly 1E, similarly 65, and much similar 00, 04, 0A, 7B, 12, 0A, 13, 7C, 1E, 17, 1E followed by 7A. Let me check one more randomly. Let me take this element. I am going to perform this XOR operation with this element, so that I must get the resultant as 0A. Let me check it. 45, which is nothing but 0100 followed by 0101. I need to make an XOR operation with 4F. 0100, F nothing but all ones. So this would result me 110101 followed by 0000. Nothing but 10, nothing but 0A. So I have got 0A here. Now from this resultant state, let me write this as resultant state. From this resultant state, I need to take the predefined table and make a new subbyte now. So this is my resultant state. From this resultant, I need to create a new subbyte here, as we have seen earlier. Now this time, with respect to the first element, the first element of this value will act as a row, and the second element of this will act as a column, and the intersection point of that we are going to display in the first element of this part. Let me take the first row of this is 1. So with respect to 1th row and 9th column, so this is my 1th row, and I need to, this is my first row till the 9th column, and the 9th column, the point of intersection is D4, so I am considering it to be D4. Similarly, with respect to the first row and second column, the same row followed by second column, the value of this is C9, so I am placing here C9. Similarly, with respect to 1E, first row and 8th column, the point of intersection is 72, so I am performing here 72. Similarly, with respect to 6th row and 5th column. So this is my 6th row, a point of intersection where the point is getting meet with 6th row and 5th column, and this is 4D, right? So the value of this is 4D. Similarly, with respect to 0 0, the point at which 0 0 is meeting is 63. So simply I am writing as 63. 0 4, 0th row and 4th column, nothing but F2. Coming to this 0A, 0th row and 8th column, which is nothing but 67. So I'm pointing it to be 67. Similarly, with respect to 7B now, 7B, 7th row, this is my 7th row till the bth column. So the bth column I'm having is 21, right? So 21 I'm mentioning here. Now coming to this 3rd row, 1st row and 2nd column point of intersection I need to take. This is my 1st row and this is my 2nd column. So the point of intersection is C9 again, right? So C9. Similarly, 0th row and 8th column. So this is my 0th row and followed by 8th column, which is nothing but 67 again. Similarly, 1st row and 3rd column. So this is my 1st row. With respect to this, the 3rd column will be 7D. So the value of 7D is placed. Finally, with respect to 7th row and C column. 7th row, this is getting prolonged, and C column will be 10. So 1 0. Finally, coming to the last row, here the value is 1E. 1st row and eth column we need to bother about. So this is my 1st row again, and eth column, this is point of intersection is 72. So I am writing it as 72. Again with respect to 1 7, 1st row and 7th column, and this would be F0. Similarly, with respect to 1E, 1st row and eth column, the value will be 72 again, and the last element, which is nothing but 7A. 7th row I need to bother about. This is my 7th row and 8th column. This is my 8th column. The point of intersection is DA. So I am mentioning it to be DA. So this is my subbyte. In order to go for mixing a column, we need to first shift the rows. I will be shifting these rows in such a way that initially with respect to 1st row, I am going to make a circular shift of 0. I am going to perform a circular shift of 0, which means I am not going to shift anything for the 1st row. Coming to the 2nd row, here we are going to make a 1-bit circular shift. 1-bit circular shift left. Again for the 3rd row, we are going to perform a 2-bit circular shift left. And finally, with respect to the 3rd row, we are performing a 3-bit circular shift left. So initially for the 1st row, there won't be any shifting operation. So this will be as it is. The value will be D4, C9, 72 followed by 40. Now coming to the 2nd row, which is nothing but 63, F2, 67, 21. If I am making a circular shift, then obviously the value of this is moved to here, the value of this is moved to here, the value of this is moved to here, and the value of this is getting circulated to here. So this will be 63, this will be 21, this would be 67 followed by F2. So the value I am writing here to be F2, 67, 21 and 63. Now coming to the 3rd row, the values are C9, 67, 7D, 10. So with respect to 3rd row, we need to perform a 2-bit shift left circular, right? So in order to perform a 2-bit circular shift left, the value of this will be moved ahead of this, the value of this will be moved ahead of this, the value of this would be ahead of this, and the value of this would be moved to this. So this will be 67, this will be C9, and this will be 10 followed by 7D. So the same value I am writing here, 7D, 10, C9, 67. Now coming to the last, so this is completed. Coming to the last row, the values are 72, F0, 72 again followed by DA. This I need to perform a 3-bit circular shift, right? So obviously initially the value will perform a 3-bit shift left. So this will be there. This would move perform to circular shift here. After a 3-bit shift, this would perform to here, and finally after 3-bit shift, the last will come to here. So the value of this would be DA, 72, F0 followed by 72 again. Do not get confused, we are performing a circular shift left operation, not simply left operation, okay? So let me complete it. This would be DA, 72, F0 followed by 72 again. Now this is my new subbyte. After this step, we need to perform a mixed column, right? In order to perform a mixed column, we need to multiply with a predefined matrix value. Let me write the new subbyte once again. In AES, we got a predefined matrix for mixing column for an encrypted algorithm. Okay, so initially for the first step, this is my predefined matrix 2, 3, 1, 1, which is of size 4 by 4. 1231 1123 3112, which is nothing but 4 by 4. This I need to multiply with the first column of the new subbyte. So this is my first column, right? Multiplying with D4, F2, 7D followed by DA. So this is of value 4 by 1. It is going to get common with this, so I can perform a matrix multiplication according to mathematics. And perform this multiplication, we can compute this in a way where I am going to multiply this element with respect to D4, right? So 2 multiplied with D4, the second element 3 I am going to multiply with this F2, 3 multiplied with F2. Similarly, the third 1 multiplied with 7D. So 1 multiplied with 7D. Finally, the last element of this first row I am going to multiply with this, the last row. Nothing but 1 multiplied with DA. Now pay attention here. This is the general normal computation of matrix, right? Within this matrix, you need to perform an XOR operation at each and every point of time. So here we need to perform an XOR operation. Here as well as here we need to perform an XOR operation. Like this, you need to complete this every state. So the next state will be 1 multiplied with D4, performing the X operation with 2 multiplied with F2, performing the XOR operation with 3 multiplying with 7D, again performing the XOR operation with 1 multiplying with DA. Similarly with respect to the third step, 1 multiplied with D4 again with respect to 1 multiplied with F2, similarly making an XOR operation with 2 multiplied with 7D, performing an XOR operation with 3 multiplied with DA. Similarly for the last row, the 3 I need to multiply with the first row of this part, making an XOR operation with the second row. I need to perform the XOR operation with the, to perform the multiplication operation with this F2 again. Similarly with respect to 1, I need to multiply with 7D, finally perform the XOR operation with 2 multiplied with DA. These are the normal mathematical matrix computation, right? So this would generate, if you could able to complete it, this would generate a column of 19, 76, A9 and 47. Now this will be acting as my first column of the mixed row. Now coming to the second column of the subbyte, which is C9, 67, 10 followed by 72. So again we are going to perform the matrix multiplication with respect to the predefined value of 2311 followed by 1231 followed by 1123, finally 3112. Again this I need to multiply with this second column of the subbyte, which is C9, 67, 10 followed by 72. As said earlier, the resultant would be 42, 45, 18, D3. Similarly with respect to third column, we got is 72, 21, C9, F0. Again performing the matrix multiplication of the predefined matrix value 2311, 1231, 1123 followed by 3112. It is going to get computed with 72, 21, C9 followed by F0. The resultant would be BE 80, D1 followed by 85. Again with respect to the last column, finally making it to the last column of the subsystem, which is 4D, 63, 67, 72, and the predefined matrix that we got is 2, 3, 11, 1, 2, 3, 1, 1, 1, 2, 3 followed by 3, 1, 1, 2, which I am going to then multiply with the last column, nothing but 4D, 63, 67, 72. The resultant of this would be 2A, 50, 76 followed by 37. So this is the last column with respect to round 1 key, which is 2A, 50, 76 and 37. Let me fill all the keys that we have generated just now by performing the matrix multiplication. 19, 76, A9, 47, 42, 45, 18, D3, BE, 80, D1, 85. So finally this is my mixed column keys. Thereby the keys that we have generated just now are. Likewise we need to compute with respect to key and with respect to round in order to generate a cipher text.